The reason you selected this video is because you want to learn SolidWorks Basics. Yes, you came to the right place. In this video, I'm going to show you all SolidWorks Basics so that end of this video, you will be able to start working in SolidWorks. This video is part of my main SolidWorks program called SolidWorks Learning Machine. That's a very big program where more than 15 courses available. All students in that program start from zero and they become a Pro SolidWorks user within a few months through our guided learning path. But today I'm going to focus mainly in SolidWorks Basics because it doesn't matter what really you want to do, always you have to learn SolidWorks Basics and then you can move on to SolidWorks Advanced if you are serious about SolidWorks learning. So in today's video, I'm going to focus on 4 main fundamental topics such as sketch, part, assembly, and drawing. If you never touched SolidWorks before or never worked in mechanical parametric CAD software before, that is completely fine because I'm going to cover all essential basic stuffs so that you can start working in SolidWorks. We are going to do a lot. Let's get into it. Hi, this is Asif Ahmed from MCAD Skill. First, I'm going to start with SolidWorks User Interface. And then I'm going to move on to sketch, part, assembly, and then finally drawing. There are a lot I'm going to cover. So on the screen right now, as we can see, this is SolidWorks User Interface. Inside this user interface, at the center, there is one screen. This window is called Home Screen. Normally, experienced users don't use this, but as a beginner, it's best to use this because there are some tools available that very frequently you have to use. These are the tools you are seeing here. Using these tools, you can create your SolidWorks file or you can open any recently used documents, recently used folder, and some resources. So I'm going to encourage you to use this home screen, but if you don't want to, you don't have to. Now inside SolidWorks, there are 3 file formats available. Always keep in mind, it doesn't matter what you are going to do, always 3 different SolidWorks file format you have to work with: part, assembly, and drawing. So in real world environment, let's say you want to construct any specific part. For that specific part in SolidWorks, there is a part file available, that is part template. So that is SolidWorks native file format. Once you design your part, let's say you designed 3 different parts, you are going to combine all those 3 parts. You need assembly file. So in SolidWorks, there is an assembly file you can create. This is another template, that is another SolidWorks native file format. Okay. So once you design your part, then assemble it, then you have to manufacture those parts and assembly together. You have to create a drawing that is called 2D drawing. For 2D drawing in SolidWorks, they offer native 2D drawing file. So if you see here, there are 3 file formats available. But I'm going to show you a different location from where you can get access to these tools. Go right left corner, select on this arrow, select File, New. From this window, clearly you can see there are 3 file formats available. Normally you have to start with part file format because this is where you have to design your part. So most likely you are going to work with part file format. So select part, then press OK. Now this is the default user interface inside SolidWorks. Keep in mind, based on your file format, this interface is still going to be the same, but tools will be different. Right now here we can see there are so many tools available here, but majority tools are gray now. Why? That I will show you later. Let's learn about this user interface. So here we can see at top, this is title bar. Very frequently used system level tools available. For example, if you want to save any file, open any file, create any file, or print any file, those are the things available here. Then right underneath this title bar, this area is called Command Manager. All necessary tools you need to create your 3D file, all those tools will be listed inside this area. Inside this command managers, there will be few groups. If you see this line, these are groups. Few groups together will be one tab and there are few tabs available. On the left hand side, this area is called Feature Manager Design Tree. Whatever you are going to do to create your model, everything will be recorded here. Let's say you created your model using 5 features. All 5 features will be listed inside this Feature Manager Design Tree. Then on the right hand side, this area is called graphic window. This is a 3D space where you are going to design whatever you want. There are some tools available inside this graphic window at top. This is called Heads Up toolbar. If you want to see your model from any specific direction, or if you want to zoom in, zoom out, if you want to create any section view, those tools are available inside this heads up toolbar. This is the overall user interface inside this SolidWorks, but keep in mind in which environment you are in, that's important. I'm inside part environment. I'm going to open a few files and going to show you how this look like in part environment, assembly environment, and drawing environment. So right now we are inside assembly environment. Everything looks same except these tools. Because we are inside assembly environment, you are going to get a different set of tools. Now let's switch to different environment. This is drawing environment. As we can see, environment is same except tools. Tools are very different, as well as this feature manager design tree will be different based on part, assembly, and drawing. As we can see, environment in all different environments is very similar. Now let's focus on view manipulation, which means how you can control your model, which means how you can rotate or pan or zoom your model. To pan your model, press and hold Ctrl key on your keyboard and just simply press and hold middle mouse button and pan your model. If you want to rotate it, that's even easier. Press and hold middle mouse button and just simply rotate your model. If you want to zoom in or zoom out your model, just simply scroll up or down to zoom in or zoom out. Let's say you zoom out too much and you want to bring back this model inside this graphic window, just simply press twice middle mouse button. So this is how you can zoom, pan, or rotate your model. Now let's start with sketch environment. Just keep in mind, this is the workflow. You have to start with sketch, then part, then assembly, then drawing. So first thing first is I'm going to take a part file where we are going to create our sketch, and then we are going to convert that sketch into a 3D body so that we can finish designing our 3D file or part file. To take a new file, go to File, New, and from here you have to take this part file. So now I am inside this brand new part file. This is where I'm going to design whatever I want. Keep in mind, this is just a 3D environment. It's in real life, let's say you have a 3D environment here, right? We live in a 3D environment. In SolidWorks, this is your 3D environment. Here, whatever you want, you can do it. So first thing first is, if you want to design any 3D part, you have to start from 2D plane. Because on 2D plane, I'm going to design something and then I'm going to give it a depth. As soon as I apply depth, it will become 3D file. In real world, let's say you have a plane sheet where you are going to draw it. Exact same idea inside SolidWorks. This is 3D environment, but we are going to design something on a 2D plane. So let's design on something on a 2D plane. So I need some paper or some plane, something flat so that I can design something. The good part is in every part file, there will be 3 default planes. So inside this feature manager design tree, this is your part file. These are the 3 planes available. Always you are going to see these 3 planes will be available by default. Select all 3 planes. As we can see, front plane, top plane, right plane. On this 3 plane, you can start designing your 2D sketch. 2D sketch is your first step. It doesn't matter what kind of part you're going to design. Always you have to start from 2D sketch. That's by default, that's what you have to do. I'm going to create a sketch on front plane. So take a front plane, select front plane. There is one small icon called sketch. You can start your sketch using this button or go inside the sketch tab. There are many tabs available. Right now we are going to focus inside sketch. All tools related to sketch will be inside sketch tab. So go inside sketch and select this sketch tool. Using this sketch tool, we will enable sketch environment. At the same time, we have to create one new sketch where we are going to draw whatever we want. So let's activate sketch tool. As soon as I activate it, SolidWorks is asking, hey, please give me at least one plane where I can create your desired sketch. I can select any one of this plane, select front plane. This is where I'm going to draw my sketch. As soon as I select it, now I am inside a sketch environment. Now, how do you know that you are in a sketch environment? If you notice at top right corner here, if you see this icon, that means you are in a sketch environment. Now, next thing is I have to draw whatever I want inside the sketch environment. So inside sketch tab, there are many tools available. Using those tools, I'm going to add sketch entities. For example, I want to add some lines. To do this, you have to use line tool. Go inside the sketch tab. This is the line tool. There are many other tools available. For example, you want to create rectangle. Rectangle tool is available, or circle, or arc, or slot. All these tools are available by default. So activate line tool and just simply start from any point. This is a sketch center. This is fixed point, and from this fixed point you can start from fixed point or you can start from anywhere. Even though this looks like it's 3D, keep in mind it's not. We are inside a sketch environment, 2D sketch environment. Whatever I'm going to draw, we are going to draw inside 2D environment. So I draw one line, I specified my first point. Now all I have to do is specify my second point. As soon as I define my second point, I created this line. And if you notice, this line tool is still active. That means I can create multiple lines at the same time. Once I finish designing it, right click and select End Chain. Once I select it, still this line tool is active. If you see this mouse cursor, if you see this icon, means at this moment line tool is active. So that means I can create more lines. If you want to deactivate this tool, just simply press Escape key to deactivate it. Now let's create a few more sketch entities. Let's create a rectangle. Now if you see this icon, if you carefully check this icon, there are 2 corner points. Means if you want to create a rectangle, you have to start from corner and you have to define another corner. So because this is showing 2 corners, I'm going to start from left corner, then I have to define right bottom corner. Same idea, you can start from left bottom corner and then you can go up to top right corner. There are few different rectangle tools available. You can try any one of these. Let's say center rectangle. You have to start from center, then you have to define any corner. Activate this tool, select center rectangle, that means center point of this rectangle, then specify this corner. Now let's design a few more sketch entities. If you want to design circle, activate circle tool. Always make sure to check these points. There are 2 points we have to define. Select this rectangle tool. And if you notice, inside this area, this is called property manager. Inside this property manager, you will get more information every time you activate any specific tool. In this case, we activated circle tool. That's why anything related to circle tool will be available here. Inside this property manager, there are 2 different ways you can create your circle. First, circle type is selected at this moment and it says point number 1, point number 2. If you see this, that means you have to define circle center first. Then you have to define circle diameter. Now if you go with this circle type 2, in this case you have to define 3 points. Point 1, 2, 3. This is how you have to create these circles. Now activate this slot tool. Under slot type, there are 4 different type slots available. Let's go with this first type, and clearly it says you have to start from left arc center, then right arc center, then define slot width. So let's start left point, right point, and this third point. There are total 4 type slot available. Select the second type. This time I have to start from center. So go with the center, first point, second point, which is going to define slot length and this slot width. If you want to draw polygon, select it. Now for this polygon, I have to define how many sides I want. I want 6 sides. I want hexagonal polygon. And then simply select center. And as we can see, that's how very easily you can create your polygon. You can also create arc using this arc tool. Activate arc tool. This type arc is selected, which is called 3-point arc. You have to define arc starting point, end point, then arc radius. So this is my starting point of the arc, end point of the arc, then I have to define radius. That's how very easily you can add whatever sketch entities you want using all these tools. So far we learned how to create sketch entities. Now you have to control these sketch entities, because I want to design my product very precisely. Make sure this is 100% controlled design. At this moment, if I select this arc radius and drag it, this radius is changing. Everything is changing. So nothing is fully defined. You have to fully define your sketch. That's super important. Let's close this sketch and just take a new one, fresh part file, and take a new sketch on this front plane. Now inside this file, I'm going to show you how to control your sketch. Let's start with the line tool, and I'm going to start from this center point. Keep in mind, this center point is a fixed point. It doesn't float. Everything else can float, but that center point of this sketch is fixed. It's not possible to move it. So if I start from this point, this line, and put a length, Now let's try to increase or decrease this line length. I can do it. Perfect. I can also move or rotate this line, but if I try to move this left endpoint of this line, I can't, because this line's left endpoint is attached with sketch center, which is fixed by default. So always keep in mind, whatever sketch you are going to design, always you have to start from center, because that's a fixed point. We are living in a 3D space, and now in this 3D space you need some constant, some starting point that will not move. Otherwise, if you leave everything floating, then you will not be able to control all models or any items precisely. That's why you have to start from a fixed point. So let's control this line. First of all, I want to control length of this line. How you can control it? I can control it using two different items. One is dimension, another is geometric constants. Dimension is easier to understand. I'm sure you will understand that you just have to put some dimension. There is a dimension tool available inside the sketch tab, which is this dimension called Smart Dimension. Activate this tool. Keep in mind, whatever dimension you are going to apply, there is no other tools you need. This is the only dimension tool you need to create your dimension. Now select this line tool. I can apply this vertical dimension or this horizontal dimension. I did not press any button yet. All I am doing is changing this dimension position close to this horizontal position, and automatically SolidWorks is switching between horizontal and vertical dimension. If you want true dimension, go closer to this line, and as we can see, you can actually apply this true dimension of this line. But for this example, I'm going to put this horizontal dimension. Apply this horizontal dimension. Now there is a new window open where you have to put any specific value precisely. Let's put 100. So this is how very easily you can add your dimension. Now I'm going to show you how to control your sketch entity using geometric constant. Let's create a line. Now I don't want to add any dimension. Instead, I'm going to apply geometric constant. Using geometric constant, you can get more control on your sketch. Simply select this line. Once I select it, inside this pop-up toolbar, there are few options available. Using these options, I can get more control on my sketch. These are constant, geometric constant. This means horizontal constant. This option means vertical constant. Select this option called Make Horizontal. As soon as I select it, if you notice right under this line, there is a green flag. If you see flag like this, or let's say icon like this, means this is geometric constant. Now let's try to rotate this line. It's not possible because I apply horizontal constant. So you can change this line position, length, but it's not possible to rotate this line. Using geometric constant, I established that this line always has to stay horizontal. Create another line. This time I'm going to apply vertical constant. So just simply select this line, and I can apply Make Vertical, means vertical constant. Now if you notice inside Property Manager, under Add Relations, these are the possible constants for this specific selected sketch entity. So based on your selection, this relation can be different. I'm going to show you in another example. Let's finish this one first. Select this vertical. And as you can see, for this line, we have horizontal constant. For this line, we have vertical constant. Now at this moment, both lines are floating inside this space. If you remember, you have to start from this sketch center. That's super important. Now select this endpoint, press and hold Ctrl key on your keyboard and select this sketch center. Now if you notice under relations inside this property manager, now you have one additional relation option called coincident. If I select it, this line end will create coincident relation with this sketch center. This is exactly what I want. Now also, if you notice, color of this line is changed. That means this specific sketch entity is fully defined. But if you notice this right side point, this is still underdefined. This point, I can move it left and right. Now I am going to apply dimension for this line tool. Line length is fixed now. If you notice, this right side point is black now. That means this entire line is fully defined. Now select these 2 points and apply coincident relation. And if you notice, there are more options now. That's why I'm saying based on your sketch entity selection, SolidWorks is going to give you a list of possible options. Apply coincident relation. And then finally, add one vertical line, which is 55. Now create one circle. Select this circle and this line. Now, if you notice, under add relation, we have a few more different relation types available. For example, tangent and equal curve length. Let's select tangent. SolidWorks will create tangent relation between this circle and this line. Now, if I try to increase or decrease, or let's say if I try to move this circle, still there is a tangent relation between this circle and this line. So as you can see, based on your sketch entity selection, SolidWorks is going to show you different type relation. Those are possibilities. You just have to select your preferred one. So far we learned how to create sketch entities, how to control sketch entities using dimension and geometry constant. Next thing I'm going to teach you, which is how to modify sketch entities. Let's say, for example, I created these two sketch entities and I created a line. Let's put couple of dimensions for this line. From this point to this point, this is 60. And from this point to this point, this is 20. Now, I don't want this portion from this entire line. Also, I don't want this portion from this entire line. How can I modify it? You have to use sketch modification tools. Inside this sketch tab, inside this group, you have to use these tools to create different type of sketch entities. But if you notice, right beside this group, there is another group. Using this group, you will be able to modify your sketch. There is one tool called Trim Entities. Select it. Now under options, there are so many options. 99% time you are going to use this Power Trim option. So this is selected. All I have to do is press and hold left mouse button and drag it on top of these two lines. These two portions from each lines are completely gone. This is exactly what I was looking for. Just to make sure this sketch is fully defined. The reason I'm keep adding dimensions and trying to make a sketch fully defined is because that's super important. Without fully defining a sketch, if you want to move on, you can do it, but that's a very bad practice. That's why I'm focusing on a sketch fully defined. Always try to fully define your sketch. That's super important. So let's add few more dimensions. So now sketch is ready. I don't need this circle. Delete this. Now I want to close this sketch. Using this button, you can close it. Select on this icon and go inside this feature manager design tree and see what happened. This is the sketch one created. This feature is recorded. Let's say I want to create a second sketch. Let's just create another sketch on this top plane. Right click on this top plane, select this sketch tool. Now we are inside this is another new sketch environment. Just simply create one circle and close this sketch. Now if you notice, there are two sketches, sketch 1 and sketch 2. Right now we are seeing this sketch from top view. If you want to see this from isometric view or any other angle, you can use this option from heads up toolbar. Go to drop down menu of this view orient and select this isometric option. There is a shortcut available called Ctrl+7. Now inside this feature manager design tree, any feature you are going to use to create your model, everything will be listed. Right now we have two separate sketches. Let's say I want to modify sketch 1. Just simply right click and select edit sketch tool. And this will bring me inside this sketch environment. How do I know that? By verifying this icon. This icon means we are inside this sketch environment. Once I'm done, close this sketch. So far we covered sketch environment. Now next step is to convert this sketch into a 3D body. You don't need any other file format to create your 3D model. So for this 3D model, there are mainly two different environments. One is sketch environment and another is part environment. So I'm going to show you in the next step how to convert this sketch and create your 3D model. Now I'm going to create a very simple sketch, and from that 2D sketch, we are going to create our first 3D body. This is a very important step you have to remember. So let's delete these sketches. We don't need this. If you want to delete it, just simply right click on this sketch and press delete key. If you want to delete these sketches, just simply select any one of these sketches and select delete option. Now I'm going to take a new sketch on this front plane. I'm going to create a rectangle, and all I have to do is apply a few dimensions. Now if you notice, this sketch is closed profile. You can create open profile or closed profile, but 99% time in your production environment you are going to create closed profile, which is very common. So I created a closed profile. Now sketch is ready. Let's close this sketch. Now I have to convert this 2D sketch into a 3D body. All I have to do is apply thickness. How can I apply thickness? You can apply thickness using extrude tool. So far we worked inside this sketch tab. From now on, I am going to work inside features tab. Inside this tab, there are tools available that you can use to create your 3D body. So the first tool, which is called extruded boss or base. This is super important tool. Every time you create any 3D body, most likely you are going to use this tool. So activate this extruded boss or base tool. And if you notice inside this property manager, this is asking me to select at least a sketch or any plane. The reason this is asking this is because if you want to create 3D body, you need 2D sketch. So in this case, because I already have this existing sketch, I can just simply select this existing sketch, or I can create a new sketch. But in this case, I'm going to select this existing sketch. As soon as I select it, as you can see, this is giving me an option to apply thickness because of this extrude tool. Inside this property manager, all those options you are seeing here, these options are related to this extrude tool. At this moment, this extrude tool is active. Using all these options, we have to specify our extrude parameters. In this case, I'm going to apply a specific thickness. Let's go with 50. This is the preview. So far, I did not establish this thickness yet, but if you want, you can change it. There is a drag handle at the center. Using this drag handle, you can change its thickness. There is a scale available. If I hover over on this scale, I can precisely apply any extrude depth. Let's go with 50. Now press OK to accept this result. Great, we just created our first 3D body. Let's go through all steps first. You have to create 2D sketch, and then from that 2D sketch, you have to create your 3D body by applying thickness. There are two tools. Those are very commonly used tools when you create your sketch, then convert into a 3D body. First tool is extrude tool. I already used this tool. There is another tool available which is called revolved boss tool. If you have cylindrical shaped part, then this second tool is important. You can use this, but 99% time you are going to use this extrude boss tool in your production environment. Now let's take a look inside this feature manager tree. What happened? This is part file, and inside this part file, as soon as I create a feature, that feature is listed inside this part file. That means everything is recording, so that later if I want, I can change all those parameters. And inside this extrude, this is the sketch. This sketch is consumed by this extrude. Now I am going to create another extrude feature, but this time instead adding material, I am going to remove material. In this case, I added material. Because I already have a solid box, now I can remove material. This time I'm not going to create a sketch in advance. Instead, I'm going to activate extrude tool first, but keep in mind there are two extrude tools available. One is for adding material, another is for removing material. The first one we used, that is for adding material. But now I am going to use extrude cut tool that you have to use for remove material. So activate this tool. Now next to cursor there is an icon shows. That means I have to specify a plane. On that plane, I have to create my sketch. Or if I have any existing sketch, I can select that. Since I don't have any existing sketch, let's select this plane. On this plane, I'm going to create my new sketch. So as you can see, it's not just only these default planes. You can create your sketch on any flat surfaces as well. In this case, this surface is 100% flat. Now let's create a very simple sketch. Activate line tool. From this corner, create a few lines. Now I'm going to apply a few dimensions. So sketch is completely ready. Now I'm going to close this sketch. As soon as I close it, that extrude cut tool will activate automatically. Let's close it. And as we can see, this is the preview. It says Cut Extrude. That means extruded cut tool is activated already. And here I have to specify how much material I want to remove. I have to specify this depth. Let's go up to 40. Then press OK. And that's how very easily I can remove these materials. I am using same tool, but one is adding material, another is removing material. Now I am going to create one cylindrical feature. For cylindrical feature, if you remember, it's recommended to use this revolve boss or base tool. Not always you have to use it, but there are some cases you have to use it. Let me show you how to use that. For this revolve tool, you have to create a sketch. So there are two different type tools available inside this features tab. One is sketch based feature, another is applied based feature. For sketch based feature, you need sketch. In this case, this extrude tool and extrude cut tool both are sketch based feature. Without sketch, it's not possible to create this specific feature. There are some other features available where you don't need sketches. That is called applied based feature. One of the applied based feature I'm going to show you first. Then I will work with revolve tool. One of the very commonly used applied based tool is fillet. Go inside features tab, then activate fillet tool. There are so many options available. Don't focus too much inside all these options. Let's focus on basic options. You have to specify fillet type. The first type is called constant type fillet. That's a very commonly used type. Select it. All I have to do is specify any edge from this body. So select this edge and this edge. As soon as I select it, this is the preview of this fillet. I have to specify this fillet diameter. At this moment, this radius is 10. Let's go with 5. Press enter. Now this is the preview. Now press OK to accept it. As you can see, this specific feature is not a sketch-based feature. All I am doing is removing material without adding any sketch. Also, if you notice inside this feature manager design tree, in front of this last feature, which is fillet, there is no arrow. That means there is no sketch inside this fillet. But for these first two features, there are sketches. Now I am going to create a feature using revolve tool. For revolve feature, I need a sketch. This time I am going to create a sketch first. So I am going to create a sketch on this face. Activate sketch tool from sketch tab. Specify any flat surface or plane if you remember. So select this flat surface. Keep in mind, if surface is not flat, if you try to select that surface, you will not be able to select it. Now I am going to create a few lines first. Then specify geometric constant. In this case, this line will be horizontal and a few dimensions. This is a closed profile. Visually, you can tell this is closed profile by observing this color. For closed profile, it is going to give you this darkish blue color. Now sketch is fully ready. Let's close this sketch and activate revolve tool. In this case, I'm going to specify my existing sketch. Select this existing sketch. As soon as I select it, this is the preview it is showing, but this is not the result I want. In this case, because this is revolve tool, I have to specify axis of revolution. Clear this box. As an axis of revolution, I'm going to select this line. As we can see, this is the preview. Now press OK. And very easily, I created this feature. Not only that, I combined this new feature with this existing body. Now I am going to apply chamfer on this specific edge. In this case, this chamfer is applied based feature, so I don't need any sketch. Activate this chamfer tool from this features tab. This chamfer tool is activated. Go with first type under this chamfer, which is called angle distance. Then select this circular edge. Then specify chamfer value. I will go with default value, then press OK. Now keep in mind, the way I created this revolve feature, I can remove material using revolve cut feature as well. So if you notice, this is revolve feature, and there is another feature available called revolve cut. This is exact same tool. One tool is adding material, another tool is removing material. Same idea like extruded tool. There are few more tools available. Those are very important tools, such as sweep tool. You have two tools under this sweep. One is sweep boss and sweep cut. Same idea. One is adding material, another one is removing material. Now I am going to show you another very important tool that is very frequently used tool inside this part environment, which is hole wizard. If you want to create any hole, you can just simply create that hole manually. Let me show you how. So create a new sketch on this face, create a circle, then apply extrude cut. So I am going to remove material. This is one of the way you can create your hole or standard holes. But for standard holes, it's very important to use hole wizard so that you can control all holes easily. Let me show you how. Let's undo it. We don't need this specific hole. Now there is a tool called hole wizard. Let's activate this tool. Now there are so many options available. I'm going to mention only few options. Those are very popular options. Under hole type, you have to specify type of hole. So let's go with one of the very common type, counterbore. Then under standard, you can select any standard. Let's go with NC metric. Socket head cap screw. Go with M6. And now we have to specify position of this hole. To do that, go inside positions tab. And now we have to specify plane where we want to add that hole. Select this plane. And now we have to specify point. Hover over on this circular edge, and it is going to show you center point of this arc. Select this arc center, and we successfully added this hole. But I want to add this hole right at the end. This is the preview of this hole. To do that, go inside type tab, then under end condition, go with throw all. Now press OK. This is the standard hole. And good thing about this hole is, if you notice, that hole information is available inside this feature manager design tree. That's really important, because by looking into this model, it's difficult to tell what size of this hole. But you can tell this is counterbore and this is M6 socket head cap screw hole. So far we applied a few different features. Now let's say I want to go back to past and modify any existing sketch dimension or any feature. This is the power of this parametric CAD software. This is the first feature. This is recorded. This is in the history. I can go inside this feature, right click and edit it. But instead, I'm going to modify sketch. So expand this feature, right click on this sketch and select edit sketch. Now we are inside a sketch mode. As we can see from this icon. I'm going to change length from 70 to 80. Now finish this sketch and entire model will update automatically. Now I am going to create one more hole, and then I'm going to show you how to create pattern. That is another very important feature inside this part environment. So activate hole wizard tool. This time I'm not going to use counterbore. Instead, I'm going to use this simple hole. Just simply drill hole. Then we have to specify diameter. Let's go with 5.3. End condition, go with blind 12 mm. Now we have to specify position of this hole on this surface. Go inside positions tab, then specify this plane. This is where I want to add my holes. Just simply select any point. Remember, you have option to apply dimensions. If you notice, we are inside the sketch tab and we have option to apply any sketch tool. So in this case, I'm going to apply a few dimensions. Now press OK. This is our first hole. Now I'm going to show you how to create pattern. This is another very important feature you can apply. There are many different type patterns available. Under Features tab, if I select drop-down menu of this linear pattern, there are so many different variations available. Majority patterns are very advanced level pattern. There are 3 tools very frequently you are going to use: linear pattern, circular pattern, and mirror. I'm going to show you how to work with linear pattern. Select it. We have to specify direction of this pattern. I can select any plane, axis, or edge as a direction. So in this case, select this as, and this is the direction. If you want to reverse its direction, this is the button you have to press to reverse it. But my direction is correct. Then we have to specify feature. In this case, this is the feature I want to select inside this features and faces tab. Let's select this feature, and then we have to specify spacing and instances. Right now, spacing is 10 mm and number of instances 2. Let's go with 4. Now press OK. If you want to see what's happening inside this part file, then from this heads up toolbar, select drop down menu, then select this option called hidden lines visible. Sometimes this option really works well so that you can see what's happening inside this model. Sometimes it's hard. In this case, for this specific model, it's not hard to see. So I think we are good, but keep in mind you have this option here. Now let's review all together what we learned. First, we learned user interface, then sketch environment, then we learned how to convert that sketch into a 3D part file, and inside this 3D part file, how to add different features and create a solid model. Now next step is to create an assembly. If you want to create an assembly, you need a few parts. You have to assemble all parts together, and then you will create your desired assembly. That I'm going to show you next. Before I move on to assembly level, keep in mind there are a lot to cover inside this sketch and part environment. So far, I already spent almost 1 hour in this training video, and still I was able to finish just probably 1 to 2% from this sketch and part environment. If you really want to learn everything inside sketch and part environment, I need at least 10 to 12 hours, that is bare minimum, to teach you everything inside sketch and part environment so that you can get ultimate control on your sketch. If you are really serious about SolidWorks learning, you can check out my SolidWorks program called SolidWorks Learning Machine. Inside that program, you will get access to 55 hours content, and you will start from zero and you will become pro user within a few months. Everything I covered inside that program, there is a link in the description box. Make sure to check that program if you are serious about SolidWorks learning. But if you are happy with this SolidWorks basics, let's move on, continue. I'm going to show you how to assemble components together and create our first assembly step by step. Now, if you remember, for assembly file, there is a native file format available inside SolidWorks. So I'm going to create our first assembly file. Go to File, New. So far we work inside this part file. Now let's move on to this assembly file. Select it and press OK. This is our first assembly file. This is where we are going to add all parts and assemble everything together. This environment is little different. This looks same. The different thing is those tools are different. Because you are inside assembly environment, you are going to see a completely different set of tools. I'm going to change this background. You don't have to. If you select this drop down menu option, you will be able to change this scene, but you don't have to. Sometimes I change it. Now I need part file that I'm going to insert inside this assembly file. There are two files I'm going to show you that I'm going to insert. This is part 1 that I'm going to insert, and this is part 2. Now one shortcut I'm going to teach you. If you want to switch between files inside SolidWorks, there is a shortcut for this. Press and hold Ctrl key, then press Tab key just only once, and it is going to show you this open document window. From here you can select it, or just simply keep pressing Tab key and it is going to switch between all open files. Let's say I want to see this file. Toggle few times. Now P1 is active. Just simply release your Ctrl key. And as we can see, very easily we can switch. Now first thing first, I have to bring this file inside assembly environment. There are a few different ways you can insert your part. One very common method is you can use Insert Components tool from this assembly tab. This is a very frequently used tool. Most likely you are going to use in your production environment very frequently. Activate this tool. There is a browse button. Using this browse button, you can go to your directory and select any specific file. Or you can open any file directly from this Open Documents window. Inside this box, this list of files you are seeing here, all are right now open inside this SolidWorks. Now select P1. As soon as I select it, it is attached with this cursor. and now I have to insert it. I can insert it anywhere. There is a small toolbar. Using this toolbar, you will be able to orient your part. Let me show you how. As we can see, based on X, Y, Z, you can orient your part. Now I have to insert this part inside this 3D environment. Keep in mind, if you work inside part environment or assembly environment, these are 3D spaces. So inside 3D space, it will just float in that 3D space. So you need some fixed point. If you remember, inside this sketch, there was a point that was fixed point. The same idea inside this assembly environment. There is a fixed point which is called assembly origin. I want to attach this first component to this origin. To do this, I have to see that origin. Right now I can't see, this is just blank. You have to show that origin. How we can show it? Go to this heads up toolbar, select this drop down menu of this visibility. Then there is an option available. This is toggle button called view origins. Select it. Now this center origin you are seeing here, this is assembly center. And there is another origin you can see right underneath this cursor, that is this part origin. I want to connect this part origin with this assembly origin. To do this, just simply hover over on this assembly origin. And this part origin will snap to this assembly origin. It is not applied yet because I did not select it yet. Now I just have to press once, left mouse button, and great, I just placed my first component. And if you notice inside this assembly file, this is our first component. Let's try to move this component. I can't move it because this part is fixed to this assembly origin. That's very important. Every time you work in assembly environment, always keep in mind the first part you are going to bring, you have to fix that part. You can bring, let's say, 10 parts together, but one of the part has to be fixed, and based on that fixed part, you are going to add all other assembly parts, and you have to apply MCAD constant that I'm going to show you a little bit later. But our first component is fixed. Now inside this Feature Manager design tree, in front of this file name, which is part 1, there is F icon. If you see this F, that means this part is completely fixed. So we got our fixed part. Now I'm going to add more parts. Activate Insert Components tool, select part 2. This time I don't need to fix this part with any origin. I want to place this second part based on this first part. So just simply randomly select any point inside this 3D space. And I don't need to see these origins anymore, so let's hide it. Now if you take a look into this assembly file, I can move this part, but it's not possible to move. And even if I try to move it, if you notice there is a text, it shows the selected component is fixed. It can't move. Now if you notice inside this Feature Manager design tree, for this second part, there is minus icon in front of this part. That means this part is not fully constant. At least 1 degree of freedom available on this part. Right now all degree of freedom available, but this minus means at least there is 1 degree of freedom available. Now let's place this part 2 at this corner. How can I do it? You have to use MCAD tool. Using MCAD tool, you will be able to position any parts precisely. That MCAD tool is available inside Assembly tab. MCAD tool. Activate this MCAD tool. There are so many options. Let's focus on standard MCAD type. Go under standard type, and then you have to specify MCAD type. You can select your MCAD type first, or you can select your geometry. Based on that geometric selection, SolidWorks is going to suggest you any specific MCAD. Since I know exactly what MCAD I want, I'm going to specify that MCAD. In this case, this coincident MCAD. Select this MCAD type, coincident, between this face from this fixed part and this back face from this floating part. All I have to do is select this face. As we can see, this first face is recorded already. Select this second face. And this is highlighted here. If you take a look from top view, these two faces attached together using coincident relation. There is one small toolbar shows. If you remember, I was saying based on your geometry selection, SolidWorks is going to show you possible MCAD type. These are the possible MCAD types based on this selection. Right now, coincident is selected, but if you want, you can select any one of these MCADs. Let's go with coincident and select OK. Now let's try to move this part. I can move it anywhere, but if you notice from top view, even though I'm moving it, but these two surfaces are attached always because there is one mate available between these two surfaces. Let's apply a few more mates. Apply mate between this surface and this surface. And again, I'm going to apply coincident relation. Now on this part, there is just only 1 degree of freedom available. Let's try to move it. And as you can see, I can move it. Now as a beginner, you will find it's difficult to track which degree of freedom available after applying a few mates. The best way you can find out is apply 1 or 2 mates, then try to move that part. And then you will find out which motion is available. For this specific part, clearly we can tell there is one motion available which is up and down. Let's restrict that motion, apply third mate between this face and this face. Now let's take a look into this part from front view. These two faces are connected together, as well as these two bottom faces and those two back faces. So this second part precisely positioned at this corner, that's how very easily you will be able to apply your mate tool. Now I'm going to show you a few more mate types. I'm going to bring a few more models. Select Insert Components, select Browse. Now select these two parts together, press and hold Ctrl key and select these two together and select Open. Just simply select any random points and insert these two parts. Now first thing first is I want to place this part at origin. I don't need these first two parts, so select these two parts together by simply selecting this window selection. As we can see, these two parts are selected. All you have to do is press the Delete key on your keyboard and all you have to do is select Yes to all. Now I already inserted these two parts inside assembly. How can I fix this part at the origin of this assembly? To do this, there are a few different ways you can do it. This is base. For this base, you can apply coincident relation between part origin and assembly origin. In this case, I'm not going to activate mate tool first. This is a shortcut. First, select those specific geometry or entity. In this case, I selected this assembly level origin and this part level origin. Now, one thing keep in mind, under this assembly, this origin is assembly level origin. If you go inside part file and expand it, you are going to see another origin that is part level assembly. I selected these two assemblies together by pressing and holding Ctrl key. Now I'm going to activate mate tool and let's see what happened. As soon as I select it, SolidWorks will find that between these two selected entity, these are the possible mate type, and automatically first one is selected, which is coincident, and this is the one I want. So press OK. And you can see that F is not available in front of this part file, but there is no minus sign. If you don't see minus sign, that means that part is fully defined. There is no degree of freedom available. So let's try to move it. We can't move it. Now I'm going to place this part somewhere here, activate mate tool. This time I'm going to select this edge and this edge. Apply coincident relation. Then apply another coincident relation between these two faces. Press OK. Looks like this part is placed perfectly. It seems like there is no degree of freedom available for this second part. But as I mentioned earlier, there is a minus icon, which means this part is not fully fixed. Let's try to move it and see how this part can behave. This is acting like a hinge. The reason it's acting like a hinge is because there are two edges are connected together, not two faces. This is the difference. Now, if you really want to restrict its motion, all you have to do is you can apply parallel relation. There are a few different ways you can do it. One of the way is you can apply parallel relations between these two faces. This is showing coincident. You don't have to go with coincident. You can go with parallel relation. Press OK. And as we can see, second part is also fixed. So this is how you have to keep adding parts and you have to apply mates. There are so many different type mates available. Very frequently, you have to use this coincident, parallel, and concentric mate. These are very commonly used mate. There are some advanced mate available. Inside advanced mate, there is one mate very frequently you have to use, which is this width mate. Now, if you want to evaluate anything inside this assembly or even inside part file, there are some evaluate tools available inside this evaluate tab. Keep in mind this tab is available inside part file as well. Very frequently used tool is measure tool, which is available inside evaluate tab. Let's say I want to get a length or any angle or center of gravity position. Those informations you can get from this measure tool. Select this as it will give me length of this line. As you can see, this is the length of this line. Clear this section, right click and select delete. I want to get a dimension between this face and this face. Just simply select these two faces. This distance is 100. You can get that information from here as well. Great. So far we learned how to create assembly file, how to bring components, then step by step position those components precisely, and then finally how to evaluate part using evaluation tools. Now next step is I have to create a drawing file. Once you create part file, then assemble it together, then create an assembly file. Your end goal is to manufacture those parts. How you can manufacture it? You have to create 2D drawing where you are going to add all informations inside 2D drawing, then give it to your manufacturer. They will see the drawing and they will make that part for you. So now next step is to create drawing file. I'm going to show you how to create the drawing file and how to add all annotations. Now let's create a drawing file first. If you remember, in SolidWorks there are 3 native file formats available: part, assembly and drawing. So I'm talking about that file format. Now go inside file, select file, new. So far we worked with part file, assembly file, and now we are going to work with drawing file. Select this drawing file and press OK. Now we have to specify sheet format. Don't change anything, just press OK. And it is going to take default template. You don't have to learn what is default template. Just simply press OK. And now this is the environment. Keep in mind this is not the 3D environment. Now we are in a 2D drawing. So this is 2D environment now. And this is the template. In this template, if you want, you can modify everything. For every single company, they have their specific template. So anything you are seeing here, everything is modifiable. Now I am going to insert my first model here. And if you notice, all those tools are a little different. Because this is drawing tool, all tools related to drawing will be available inside this drawing file. Also inside this feature manager design tree, this environment is very different. There are 2 folders available. One is annotation, there is nothing inside it. Then there is a sheet 1. This is important. This is that sheet 1 you are seeing here. Let me add a few more views, then we will talk about this sheet 1. Now I want to add any model. To do this, I have to use model view tool from this drawing tab. Activate this tool. You can specify any model or any 3D file from this SolidWorks open document, but I want to use a completely different file. Select browse and use this file. Now I can insert this file. Before I insert it, let's go inside this model view. There are so many options. This option is super important, orientation. How do you want to orient your part? Right now, I can't see the preview. If you want to see the preview, here is the preview. Select it. Now you can see the preview. But do you want to insert one view or 2, 3, 4 views together? Or do you want to insert one view, then manually add all other views? Everything is possible. I'm going to insert 4 or 5 views together. If you notice under orientation tab, there is one option called create multiple views. Right now, one view will create if I select once inside this drawing. So activate this option. Right now, this front is selected. Also activate right, top and isometry. And as we can see, there are a few boxes. Now simply press OK. And all 4 views are available now. But if you want to change orientation of this model, you have to select parent view. In this case, this is the parent view. All other views are child view. Let's say you want to change orientation of this view. It's not possible because this view is connected with this parent view. If you change orientation for this parent, child views are going to change. Let me show you how. Select this parent view. Right now, this is the front and specify bottom. It is asking me, do you want to change this orientation? Dependent drawing views will be affected. It is talking about child view. So press yes. This is showing from bottom and all other views are updated. There are many other controls you have. For example, you have control on this display style. By default, this third option, hidden lines removed, is selected. Select the second one, which is hidden lines visible. You can change its scale. By default, it is using this sheet scale. So inside sheet, by default, there is one scale mentioned. As we can see, this is scale 1 by 1. But if you want, you can change its scale. Select use custom scale. Very easily, as we can see, you can change this scale. Now let's learn how to add different type annotations. For example, if I want to add any dimensions, I have to use dimension tool. Inside annotation tab, you can use any tool to add any specific annotation. For example, if I want to add dimension, this is the tool I have to use. If I want to add note, this is the tool I have to use. For balloon, this tool. For surface finish, this tool. For weldment, this tool. For hole callout, this tool, and so on. Let's go with this smart dimension tool. I want to apply angle, so just simply select these two lines, and as we can see, this is the angle. Let's apply this dimension, select these two lines. Before I press OK, right underneath this mouse, there is a circle available. Using this circle, you can specify position of this dimension. Select it, and this is the position. Let me do it again, you will understand better. Select this line, move my cursor on bottom half of this circle, how this dimension position is changing. There is one hole here. For this hole, I am going to use hole callout. Activate this hole callout tool. Just simply select this hole, and it is going to extract all necessary information manufacturer need, and it will insert that information inside this hole callout. This is why it's important to use hole wizard tool inside your part file. If you want to add center line, you can do that using this center line tool. Activate center line tool from here. I'm going to select these two lines and see what happened. As soon as I select it, it is going to create center line between these two lines. Now select this center mark, press delete key. If you have a situation where you have to add center mark, there is a tool available under annotation tab called center mark. Activate this tool. All you have to do is select this circle and it will create center line. So far I completed 4 fundamental topics in SolidWorks such as sketch, part, assembly and drawing. Please let me know what do you think about this SolidWorks basic video. If you want me to make any in-depth video on any specific topics, make sure to let me know. I will go through all comments and I will try to pick any specific topics, and in the future I will try to make video on that topics. If you really want to learn SolidWorks, these are the 4 fundamental topics. You really have to spend a lot of time. You have to watch 20 to 30 hours video so that you can get all necessary information inside these 4 topics. Perfect, you just finished SolidWorks Basics. Now let's talk about what's going to happen next. If you are really serious about SolidWorks, this basic is really not enough. If you want to learn SolidWorks Essentials, you have to go through at least 10 to 15 hours videos so that at least you will cover SolidWorks Essentials. Now, if you are serious about SolidWorks learning, then there is a program I am offering that is called SolidWorks Learning Machine. This is a very big program. There are more than 15 courses available, 55 plus hours video content available in that program. You are going to start completely from zero, and after few months, step by step through our guided learning path, you will become a pro SolidWorks user. If you are really serious about SolidWorks learning, then make sure to check out our SolidWorks Learning Machine program. There is a link in the description box. Also, I created a webinar where I discussed how you can become a pro SolidWorks user within a few months without wasting too much time. Instead of spending 4 to 5 years, you can become Pro SolidWorks user within 4 to 5 months. Thank you for watching this video. See you in the next video. Bye.